most venomous animal on Earth lives here. So does the most venomous fish. So does the most venomous snake. And the largest reptile still walking the planet. They all share one body of water, the Pacific, the biggest, deepest ocean we have, and the one that has quietly gathered more ways to bring a life to its end than anywhere else on the map. Some of them are longer than a bus, some are smaller than a golf ball, and somehow worse. A few can switch off a human heart in about the time it takes to read this sentence out loud. What follows is a catalog of the 20 most dangerous and brutal animals in the Pacific, ranked less by size than by what they can actually do to whatever is unlucky enough to be in the water with them. We're starting with one you will never see coming. And I mean that literally. It's almost completely transparent. Before we go under, do one thing for me. Tell me where you're watching from and what time it is where you are right now. Country and clock down in the comments. Big's jellyfish. A single one of them carries enough venom to bring down 60 grown adults, and it can do the work in under 3 minutes. That's the box jellyfish, Chironex fleckeri. And before we get to how it does that, you should know the part that makes it worse than the number suggests. You can't see it coming. It is almost perfectly clear. A pale bell drifting through the shallow, sunlit water off northern Australia and across the tropical Pacific, exactly where people wade in up to their waists. It's about the size of a basketball with tentacles trailing behind it that can reach 3 meters. And here's the first thing that doesn't fit. Most jellyfish are passengers. They float where the current takes them, no say in the matter. This one drives. It swims, actively, deliberately at up to 2 meters per second, and it does it to hunt. A jellyfish with a destination is not something your brain is built to expect. Now, those 3-meter tentacles are lined with millions of tiny cells, and each cell holds a coiled, harpoon-shaped thread under enormous internal pressure. Touch one, and it fires. Not in the way a mussel fires. This happens in less than a millionth of a second, one of the fastest movements produced by anything alive, on land or in the water. Thousands of microscopic barbs go off at once, and each one delivers a cardiotoxin that goes straight for the heart. Newer work in biophysics suggests the venom actually punches holes in red blood cells, letting potassium flood the system all at once. And that surge is what short-circuits the heart's electrical rhythm. It doesn't stop the heart the way you'd picture. It locks it, clenched, mid-squeeze, unable to let go. And here's the detail I keep coming back to. This animal has 24 eyes, not light-sensitive spots, real eyes, clustered in little structures around the bell, some with lenses and retinas, capable of forming actual images of the world. It can see a swimmer. It can see a piling to steer around. And it has no brain, nothing in the center to sit and process any of it. Just a ring of nerves passing signals around. So it sees the Pacific in full, and it doesn't think a single thing about it. It uses all of that on small fish and shrimp, holding them in that invisible net and stunning them on contact so they don't thrash and tear the delicate tissue on the way to the mouth. 24 eyes, no brain, and a trigger that goes off in under a microsecond. It is the most venomous animal we've ever found, and it has the intelligence of a garden gate. Blue-ringed octopus. Stay in the shallows, though, because the next one is smaller and, if anything, more unnerving. It's the size of a golf ball, and people have held it in the palm of their hand without knowing what they were holding. The blue-ringed octopus goes about its whole life looking like nothing at all. A drab, mottled brown thing tucked into a shell or a crack in the reef, small enough to sit in a coffee cup. That's the point. You only see the color when it's already too late for the animal that made it show. Threatened, it lights up in milliseconds. The dull brown drops away and dozens of electric blue rings flare up across its body, pulsing, almost neon. People describe it as beautiful. It is beautiful. It is also the clearest warning label in the ocean. Those rings aren't decoration. they mean back away. And the animals that ignore them tend not to get a second lesson. It pulls off that color change through muscle control of thousands of tiny pigment cells, expanding and contracting them faster than you can blink. But the color is the honest part. The dangerous part is quieter. In its saliva, the blue-ringed octopus carries tetrodotoxin, and it doesn't even make the stuff itself. Colonies of bacteria living in its salivary glands do the manufacturing, and the octopus just carries the result around like a loaded tool it borrowed and never gave back. That toxin blocks the sodium channels in your nerves, the little gates that let nerve cells pass a signal along. Close those gates, and the messages stop moving. The brain keeps sending orders. The muscles simply never receive them, including the ones that run your breathing. Here's the part that sits with people. The bite barely registers. The octopus has a small beak, and it can nip through skin so lightly that a person often doesn't feel it happen. There's no jolt of pain to warn you. What comes instead is a slow slide. Coordination going, vision blurring, the body getting heavy, while the mind stays completely clear the whole way down, fully awake, fully aware, and unable to move or speak or ask for help. Gram for gram, this animal is carrying something around 1,200 times stronger than cyanide, enough in one golf ball body to affect more than 24 people. And there is no direct antidote, only keeping someone breathing by machine until the toxin wears off on its own. And it's clever, which somehow makes it worse. These octopuses use tools. They'll drag a discarded shell or half a coconut into position and build themselves a little bunker to ambush crabs and shrimp from, waiting, unseen, in a fort they assembled by hand. A creature this small, this smart, this quietly armed, sitting in a shell it chose, is not a thing most people picture when they think of what can go wrong in ankle-deep water. And snail, which brings us to the one that really shouldn't work at all. Because so far we've had speed and we've had stealth. This next one has neither. It is one of the slowest animals in the entire ocean, and it hunts some of the fastest. Meet the cone snail, Conus geographus, a marine snail with a shell so clean and patterned that people pick it up off the sand to take home. That's roughly the worst mistake available on a tropical beach. Inside that decorative shell is one of the most complex chemical arsenals in the natural world, and the snail moves at the pace you'd expect from a snail. It does not chase anything. So think about the problem it's solved. It eats fish, quick, darting reef fish that could clear the area with a single flick of the tail. A creature that's slow catching a creature that fast should be impossible. It isn't. And the way around it is one of the strangest things in this entire list. Before it strikes, the cone snail releases a cloud of insulin into the water around its target, a special, fast-acting form it produces for exactly this. The fish swims into it, and its blood sugar collapses almost at once. It goes sluggish, then dazed, then drifts, dropping into a kind of chemical fog it can't swim out of. The snail hasn't touched it yet. It has simply lowered the fish's blood sugar out from under it and waited for the lights to dim. Then, and only then, it extends a thin, flexible tube and fires a single hollow barbed tooth like a tiny harpoon, loaded with a venom built from hundreds of separate compounds. After that, it opens a mouth that stretches like a bag and takes the fish in whole, still limp. Fishermen have a name for what that venom does to a person, and it's grim in a very matter-of-fact way. They call it the cigarette cone, the idea being you'd have time for about one cigarette before things became serious. There's no antidote. Without machine-assisted breathing, the survival rate for a serious sting sits somewhere around 30%. And here's the turn, because not everything on this list ends in a shadow. Scientists took that impossibly complex venom apart, and inside it, they found a compound that became a real painkiller, one roughly 1,000 times stronger than morphine, and, unlike morphine, one that doesn't pull people into dependency, Because it works on a completely different set of channels. The slowest hunter in the Pacific, packing a chemistry set most labs would envy, and one of its weapons now sits in a pharmacy. The ocean's least likely predator turned out to be one of its most useful. One, a great white shark. Somewhere off the coast of California, a seal is swimming at the surface, doing everything right, staying near the group, watching the water around it. It never thinks to look straight down. Below, in the dark, something has been holding position for a while, reading the seal's silhouette against the bright ceiling of the sky. Then it moves, straight up like something launched, and the first sign the seal gets is also the last. That's how the great white shark, Carcharodon carcharias, solves the surface, not by chasing across it, but by coming up through it. This is the largest predatory fish alive, shaped by millions of years into something close to a purpose-built machine. And it works the temperate edges of the Pacific, California, southern Australia, the cold, productive waters where seals and sea lions gather. It's the ambush from below that defines it. A great white keeps to the gloom, where its dark back blends into the deep, lines up the shape overhead, and comes up so fast and so hard that more than a ton of animal can leave the water entirely. There's a name for it: breaching, and it looks impossible the first time you see it. An animal the weight of a small car, airborne, having hit close to 40 kilometers an hour on a vertical line. That single opening strike is the whole plan. It's built to land once with everything, and let the ocean do the rest. The jaws behind that strike close with something in the range of 1.8 tons of force, enough to go through bone the way you'd snap a dry twig. But the part that should genuinely unsettle you isn't the bite. It's how the shark finds the thing it's biting. Scattered around its snout are hundreds of tiny pores filled with a conductive gel, called the ampullae of Lorenzini, and they read electricity. The faint fields thrown off by a muscle twitching, a gill flexing, a heart beating. In total darkness, or under a layer of sand, a great white can pick up the electrical signature of a living animal trying to hold still. Holding still doesn't help. The heartbeat gives it away, and now the part that argues against the whole reputation. The great white is the monster of 100 films, the ocean's designated villain, and yet most of its encounters with people aren't hunts at all. A shark has no hands. When it meets something it doesn't recognize, a surfer, a paddleboard, an unfamiliar shape, it investigates the only way it can, with its mouth, in what researchers call an exploratory bite. It's checking, not choosing. The tragedy is only in the arithmetic. An exploratory bite from a great white is still 1.8 tons on a jaw lined with serrated teeth. And a curious nibble from an animal that size does damage a person cannot walk away from. It isn't malice, it's the equipment. Here's where it gets strange. Satellite tags on Pacific great whites turned up something nobody can fully explain. Every year, they leave the rich coastal feeding grounds and swim far out into a barren stretch of open ocean, halfway to Hawaii, a place with no obvious reason to go. So empty that scientists just call it the White Shark Cafe, and once they arrive, they dive. Again and again, down to 1,000 meters and back, in water that looks like nothing on the map. Feeding in the deep, courtship, something we haven't guessed yet. The honest answer is, we don't know. The most studied predator in the sea keeps a standing appointment in the middle of nowhere, and it hasn't told us why. Tiger shark. If the great white is precision, one animal, one strike, one plan, the next shark is the opposite. It doesn't specialize. It doesn't need to. Take a guess at what's been pulled out of the stomach of a tiger shark, and then go further because you're probably underselling it. Car license plates, whole tires, cans of paint, bags of charcoal, boat cushions, tree branches, other sharks. The tiger shark, Galiocerdo cuvier, is the reason eats anything, is not a figure of speech in the Pacific. Its stomach acid is potent enough to break down materials that shouldn't be food by any reasonable definition, and its appetite runs on a simple rule: if it fits, it's worth trying. That lack of pickiness is exactly what makes it a problem. The great white is the one people fear, but it's the tiger shark that ranks second in the world for incidents with humans. And where the great white checks and often leaves, the tiger shark tends to commit. It rarely lets go of something once it's decided. Part of that is the tooth. Most sharks carry teeth built to grip and puncture. The tiger sharks are curved and serrated along the side, closer to an industrial saw blade than a dagger. Working with a side-to-side shake of the head, those teeth cut through things other sharks can't touch. The shell of a sea turtle, for one, which the tiger shark opens like it's slicing bread. It's the only shark that reliably gets through a turtle's armor, and it does it almost casually. For something over 5 meters long, it also goes where big sharks aren't supposed to. Tiger sharks will cruise water less than a meter deep, right up against tropical beaches, and their vertical striping breaks up their outlines so well against the rippling light that a swimmer could be sharing the shallows with one and never register it, especially at night, which is when it prefers to work, in the warm Pacific archipelagos like Hawaii, where it's the leading cause of serious trouble in the water. And here's a habit that's almost too on the nose. Tracking studies found that tiger sharks, in the Central Pacific time, long migrations, thousands of kilometers of open ocean to arrive at a particular set of islands during the exact weeks when albatross chicks are learning to fly. The young birds launch off the cliffs, misjudge it, and drop into the water. The sharks are already there, waiting at the surface for a meal that quite literally falls out of the sky. It's not desperation. It's a reservation, booked a season in advance. Bull shark. So we've had the ambush artist and the one that eats the world. The third shark breaks the rule you didn't know you were relying on. The one that says you're safe once you leave the sea. You're not. The bull shark, Carcharhinus lucus, swims up rivers. Most sharks would perish in fresh water. The balance of salts inside their bodies is tuned for the ocean, and drop them into a river, and the physics turns against them fast. The bull shark rewrote that. It can adjust the chemistry of its own body, dialing the levels of urea and salt in its system up or down, so it moves between the salt of the open Pacific and the fresh water of a river without missing a beat. Its kidneys reabsorb salt with extreme efficiency, and a specialized gland handles the rest, keeping its internal chemistry stable at any salinity. Bull sharks have turned up hundreds, even thousands of kilometers inland, in rivers and lakes, in water where the last thing anyone is watching for is a shark. That's the danger. Not that it's stronger than the others, but that it's somewhere your guard is completely down. It compounds the problem with poor eyesight. A bull shark's eyes are small, and its vision is weak compared to other sharks. But rather than slowing it down, that pushes it toward hunting in murky, churned-up shallows where sight barely matters, and it works by sound and vibration instead. Murky water, weak eyes, and a target it can't quite make out is a formula for mistakes, and a mistake from this animal is not a small one. Pound for pound, it's been measured with the strongest bite of any shark, over 5,900 newtons, stronger than a young great white's, packed into a stockier, blunter frame. There may be a reason it's so quick to commit too. Researchers looking at what drives the bull shark's aggression found circulating testosterone at levels higher than in any other animal they'd measured, on land or in the sea. That's the chemistry behind its habit of treating anything in its territory as a challenge to be dealt with immediately. Its method has a name that tells you everything: the bump and bite. It rams first, driving that flat, hard snout into whatever it's sizing up to knock it off balance, and then it moves in. No warning shot. Just the shove, and then the follow-through. Stonefish. Everything so far has been out in the open water. Now look down. Because the floor of the Pacific has its own set of rules, and the first one is that some of the rocks are not rocks. The most venomous fish in the world does not chase anyone. It doesn't need to. It just waits to be stepped on. The stonefish, Synancea verrucosa, is a lumpy, warty, mud-colored thing that sits on the reef floor and does the single most effective thing an ambush animal can do. Absolutely nothing. It can hold perfectly still in one spot for days at a stretch, long enough that algae and grit actually begin to settle and grow on its rough skin, until it stops looking like a fish at all and becomes indistinguishable from a lump of dead coral or a chunk of stone. You could look right at it and see the sea floor. That's the whole trick, and it's why people don't get hurt swimming near a stonefish. They get hurt walking on one. Running down its back are 13 spines, and each one works like a hypodermic needle standing on end. At the base of every spine sit 2 venom glands. Put weight on the spine, a bare foot say, and the skin sheathing it is forced down, squeezing those glands and driving the venom up through the spine and straight into the tissue. Exactly the way a syringe delivers a dose. These spines are stiff enough to go through the rubber sole of a dive boot, so just wear shoes is not the safety net people assume. And the venom they carry produces what is, by a wide margin, the worst pain in the sea. People who felt it describe wanting the limb gone rather than keep feeling what it's doing. Biochemists pulled a protein out of it called stonus toxin, and part of what makes it so severe is what it does to blood pressure. It drops it so violently, and so fast that the whole event can mimic a heart attack within minutes. And here's the twist that reframes the entire animal. All of that, the 13 loaded needles, the strongest fish venom on record, it never once uses to hunt. The venom is purely a shield. When the stonefish actually goes after a meal, it doesn't poison anything. It waits for a small fish to drift a few centimeters from that disguised mouth, and then it opens its jaws in about 15 milliseconds. So fast it creates a pocket of suction that pulls the prey in whole before the prey has registered a single thing moving. The most venomous fish alive is, from its dinner's point of view, not a venom problem at all. It's a vacuum. The venom is only for anyone foolish enough to touch it, which, on a reef floor full of rocks that are rocks, is easier to do than it sounds. Smooth stingray. Not everything hiding in the sand is small, though. Stay on the bottom and picture something the size of a car door disappearing under a layer of sand so thin it shouldn't hide anything. That's the smooth stingray, Bathytotia brevicaudata, the largest stingray species in the world. A creature that can stretch past 4 meters including the tail, span more than 2 meters wing to wing, and tip the scales at over 350 kilograms, and yet vanish under a light dusting of sediment with only its eyes showing. You know this animal even if the name doesn't land, because a stingray is what brought the life of the naturalist Steve Irwin to its end on the Great Barrier Reef, a man who had spent his whole life within arm's reach of the most dangerous creatures on the planet, undone in an instant by one of the gentlest. And that's the thing to sit with. Stingrays are docile, genuinely, reliably calm, curious even, tolerant of divers, content to be watched. What happened was not aggression. It was speed. When a ray feels cornered or trapped against the surface, or pinned so its escape route is cut off, it does one thing on pure reflex. It whips that muscular tail up over its own body, scorpion style, and drives the barbed spine at the tip into whatever is holding it there. It's a defensive reaction, over in a fraction of a second, far faster than a human can react to. And even the world's greatest expert on dangerous animals could not have moved in time. The spine itself is a nasty piece of engineering. It's coated in a sheath of tissue that tears as it enters, releasing a venom that damages tissue around the wound. But the truly brutal part is mechanical. The barbs point backward, Going in, the spine slides like a knife. Trying to pull it back out is when the design does its work. The backward-facing barbs catch and drag through blood vessels and muscle on the way, so removing it does more harm than the entry ever did. It's a shape built to be easy to receive and terrible to return. There's one detail about that venom that's oddly useful to know. Elasmobranch researchers found the toxins in a stingray's spine are made of unstable proteins that fall apart in heat, which is why the most effective first response to a ray sting isn't ice, it's the opposite. You put the limb into water as hot as the person can stand, around 45 degrees, and the heat breaks the toxin down before it can finish. The remedy for one of the ocean's most feared wounds is, essentially, a very hot bath. Bobbit worm. Now for the one that genuinely belongs in a horror film. You're standing on a stretch of the seafloor, flat, sandy, empty, the kind of bottom you'd cross without a second thought. Buried directly beneath it, running up to 3 meters long, is a creature you cannot see and would not believe. The bobbit worm, Eunice aphroditoa, spends its life dug into the sand with only 5 thin antennae poking out. That's the entire animal above the surface. 5 little threads, waiting. And when a fish or a crab brushes one, the worm comes up out of the sand with such mechanical violence that it frequently cuts the prey clean in half on the strike itself. Not overpowers it, not grips it. Divides it in the first instant, before anything else happens. And it does this with no eyes, none, all of that speed and precision runs, entirely on chemical sensors and pressure reading. In those antennae, it feels a footstep in the water and launches at it blind. The mechanism is its own small nightmare. Tucked inside the worm's body are jaws of extremely hard chitin, and when it strikes, it throws its entire throat outward, the whole pharynx turning inside out like a glove being pulled off a hand, to reveal serrated pincers that snap shut with the force of a released spring. Then it drags whatever's left down into its burrow, into total darkness beneath the sand, and finishes there. Here's how you find out you have one. Public aquariums in the Pacific region have quietly lost fish for months on end, a tank steadily emptying, no cause anyone could spot, staff baffled. In more than one case, the answer only came when they broke the whole display down and dug through the decorative rock. And there it was, a giant bobbit worm coiled inside, that had ridden in years earlier as a tiny hitchhiker buried in a piece of live rock and had simply been growing and eating in the walls the entire time. Not a break-in, a tenant nobody knew they'd signed. Giant moray, which leaves the classic monster of the reef, the one waiting in the dark cave for something to make a mistake. Except the giant moray isn't scary for the reason you think. The giant moray, Gymnothorax javanicus, is the heaviest of the morays, up to 3 meters long, jammed into the cracks and caverns of tropical Pacific reefs, mouth opening and closing on rows of long, backward curving teeth. That part matches the story. What doesn't match the story is what's happening deeper in its throat, because the giant moray has a second set of jaws. It's not a metaphor. Most fish feed by creating suction to pull prey inward. The moray can't do that in its narrow burrows, so it evolved something else, a second pair of jaws sitting back in its throat, called pharyngeal jaws. When the moray bites down with the outer jaws you can see, that inner set launches forward into the mouth, clamps onto the prey, and physically hauls it back down the throat. If that sounds familiar, it should. It is, almost exactly, the creature from Alien, and the giant moray is the only animal known to actually feed this way. To hold larger prey while those jaws do their work, it also ties its own long body into a knot, using the leverage to tear pieces free. For something built like a monster, it keeps unexpectedly clever company. Giant morays team up with a completely different fish, the roving coral grouper, in one of the rare hunting partnerships between species from unrelated families. The grouper will signal to the moray where a fish has hidden itself in the reef. The moray, thin and flexible, slides into the crack to flush it out. If the prey bolts into the open, the grouper takes it. If it hides deeper, the moray gets it. Two animals that share no ancestry, running a coordinated play. One last thing about the giant moray, and it's a genuinely strange one to end on. These animals sit near the top of the reef food chain, and over a lifetime they build up high levels of a toxin called ciguatoxin, which starts in microscopic algae and concentrates as it moves up the chain. Eat the flesh of a big moray and you can come down with ciguatera, a neurological reaction with one particularly bizarre symptom. It flips your temperature sense. Cold reads as hot, hot reads as cold. So the reef's alien-jawed cave monster has a final trick that doesn't even require it to be alive. Long after the fact, it can convince a person's own brain that ice is burning them. Saltwater crocodile. Everything up to now was born to the water. Fish, mollusks, a jellyfish, a worm. This next stretch is different. These are animals whose ancestors lived on land, walked on legs, breathed air, and then went back into the Pacific and took it over on their own terms. Cold blood, borrowed ocean, and no intention of giving it back. Start with the largest reptile still alive on Earth, and the one fact that matters most about it. It is not afraid of you. The saltwater crocodile, Crocodylus porosus, can pass 6 meters in length and weigh more than a ton, and it holds the strongest bite ever measured in a living animal, around 3,700 pounds per square inch. But plenty of animals are big and strong. What sets this one apart is the attitude behind the size. It's intensely territorial, and it treats anything that enters its water. Anything was a fair question to be answered. It has been sharing the estuaries and coastlines of the Indo-Pacific with humans for as long as there have been humans there, and it has never once decided we were off the menu. Its signature move is the roll. A crocodile's jaws are built to clamp, not to chew. There's no slicing motion in there. So once it has a grip, it solves the rest with physics. It takes hold, pulls back into deeper water, and spins its entire body along its own axis, fast, using that spin to twist portions free and to overwhelm whatever it's holding. It's crude, and it's total, and there's no counter to it from the inside. Now here's the part that ruins the mental image of a slow, heavy log basking on a bank. On land, over short distances, a saltwater crocodile is frighteningly quick. It can break into something close to a gallop. And from the water, it can launch nearly its own body length straight up, driven entirely by that enormous muscular tail. Enough to take prey off an overhanging branch or a low bank that felt like a safe distance a half-second earlier. The margin of safety people assume they have around the water's edge is mostly imaginary, and it doesn't even need to see you. Look closely at the skin around a crocodile's jaws, and you'll find thousands of tiny black dots scattered across the scales. Those are pressure sensors, and they are extraordinarily fine, sensitive enough to pick up the micro ripples and pressure changes made by an animal moving on the surface tens of meters away. A saltwater crocodile can sit fully submerged, eyes shut, and know precisely where something is thrashing at the surface, tracking it by the water alone. Stillness and silence don't hide you. The water carries the message for it. Here's where it stops being just a powerful animal and starts being a genuinely surprising one. Researchers documented saltwater crocodiles doing something no reptile was supposed to do, using tools. During the season when water birds are gathering sticks to build nests, some crocodiles float motionless with small branches balanced across their snouts. Bait. The birds come in for the nesting material, and that's the ambush. It's the first recorded case of a reptile using tools, and it means this animal, a survivor from the age of the dinosaurs, unchanged in its essentials for tens of millions of years, is not just running on old instinct. It's improvising, That's the unsettling note to leave it on. The oldest design in the room is still learning new tricks. Dubois' sea snake, from the biggest reptile in the water to one you could almost miss entirely. The next animal doesn't have a ton of muscle or a roll or a set of pressure sensors. It has one drop of the most concentrated venom of any sea snake on the planet. The Dubois sea snake, Ipisurus duboisi, lives in the coral of the Pacific, especially the Coral Sea, and its venom sits at a measured lethality of around 0.044 milligrams per kilogram. In plain terms, a fraction of a single drop carries enough to be fatal to a grown adult. There is very little margin between this snake and the top of the entire most venomous list. To live where it lives, it had to solve problems that would end most reptiles. It can stay under for up to 2 hours without surfacing, and it manages that partly by absorbing as much as a quarter of the oxygen it needs directly through its skin, supplemented by a single lung that runs nearly the whole length of its body. It also solved the salt problem, which is quietly one of the hardest problems in the ocean. A reptile living in pure seawater should slowly dehydrate and fail as salt builds up in its tissues. This snake grew special glands under its tongue that actively pull excess salt out of its body and push it back into the sea, so it can effectively drink the ocean without wrecking its own kidneys. And after all of that, the venom. The 2-hour dives, the built-in desalination. The surprise is how gentle it is. Dubois' sea snakes are docile almost to a fault. They rarely strike a diver at all unless they're badly provoked, trodden on, or tangled in a net. The most concentrated venom in this part of the ocean is carried by an animal that would genuinely prefer to be left to its own business. There's a quiet detail I want to close its section on, because it isn't about danger at all. Genetic studies found that these snakes have retuned their eyesight for the deep Pacific, shifting toward the blues and greens that dominate down there and giving up the red light receptors their land-dwelling ancestors carried. Which means this snake doesn't just live in a different world than we do, it literally sees a different one. The darkness it moves through isn't the darkness we'd see. It's a version of the ocean tuned to a spectrum we lost when our ancestors stayed on the shore. Banded sea crate. The last of the cold-blooded three won't commit to either world, and that's exactly what makes it a problem. The banded sea crate, Latticauda colubrina, spends about half its life out of the water entirely, hauled up on Pacific islands to rest, digest, and lay its eggs, and the other half hunting in the sea, where it carries a venom roughly 10 times stronger than that of a land cobra. It refuses to pick a side, and so it turns up in both, which is precisely where people don't expect a highly venomous snake to be, on the warm rocks of a beach as readily as in the reef. It never fully let go of its land equipment either. Unlike sea snakes that committed completely to the water and lost the ability to move on solid ground, the banded crate kept the broad belly scales of a land snake, the ones that let it crawl, efficiently, so it can slide across beach sand and climb coastal rocks to escape predators that can't follow it out of the water. It hedged its bets in evolution, and the hedge pays off in both directions. Underwater, it runs one of the more sophisticated partnerships on the reef. The crate threads into the deep, narrow cracks in the coral where prey hides, flushing fish out of spaces too tight for anything larger. And it does this alongside big predatory fish like goatfish and trevally, which pick off whatever bolts into the open. The snake takes what tries to hide deeper. The fish take what tries to run. Different species, one operation, and the prey loses either way. Its venom is built for one specific job. It attacks the junctions between nerve and muscle, blocking the chemical signal that tells a muscle to contract, and it works fast, in a serious envenomation. That failure reaches the muscles that run breathing within minutes. It hunts almost exclusively in the reef's tightest spaces, and the venom speed is the point. A fish it strikes has to stop struggling before it can wedge itself somewhere the snake can't follow. I'll leave the crate on its strangest feature, because it's a good one. Behavioral studies found these snakes use a decoy. The tip of the flattened tail carries color patterns and moves in a way that mimics the snake's actual head. To a predator, a bird of prey, a shark, the tail looks like the business end, so the strike lands on the harmless decoy instead of the venomous head. It's a snake that hunts in the cracks with a copy of its own face pointed the wrong way, letting everything that comes for it aim at the safe end by mistake. Portuguese man-o-war. The reptiles all had an anchor, a shore to crawl onto, a reef to hide in, a nest to return to. This next group gives that up. These are the animals of the open water column, the ones that drift, invade, and hunt in numbers, where the danger isn't a single set of jaws in a cave. It's something spreading across the water itself. Start with the one that isn't even an individual. The Portuguese man-o-war, Physalia physalis, looks like a jellyfish and drifts like one, a blue-purple float riding the warm Pacific currents, but it isn't a single animal at all. It's a colony, 4 different kinds of specialized organisms called zooids, none of which can survive on its own, all fused together and working like the organs of one larger creature. There's no central brain deciding anything. There's a committee of body parts that only functions assembled, and the assembly is what stings. The stinging part reaches a long way down. Trailing beneath that float, the capture tentacles can extend as far as 30 meters. A nearly invisible curtain hanging in the water, drifting wherever the surface takes it. And the surface is the whole point, because the float isn't just for staying up. It's a sail. That blue-purple bladder is filled with gas the colony produces itself, and it sits above the water like the sail of a boat. So when the wind blows, the man-o-war is pushed across the Pacific without spending a single unit of its own energy on movement. It doesn't swim anywhere. It catches the wind and lets the ocean deliver it, tentacles and all, toward whatever's downwind, including a beach full of people. Here's the detail that makes it worse than a live one drifting past. Those stinging cells don't need the animal to be alive or even wet. Marine toxicologists confirmed that tentacles from a man-o-war that washed up and dried on the sand days ago can still fire their venom if they're stepped on or handled. The colony can be long finished, baking in the sun above the tide line, and the weapon still works. A blue balloon that sails itself to shore and stays armed after it's gone. That's less an animal than a drifting hazard the ocean keeps restocking. Lionfish. If the man-o-war is a hazard that arrives by accident, the next one arrives on purpose and makes itself at home. And it does it while being, frankly, one of the most beautiful things on the reef. The lionfish, Pteroi volitans, moves slowly, spreads its fins like a fan of feathers, and drifts through the water with the unbothered air of something that owns the place. It's almost regal. It is also a relentless eating machine wearing 18 venomous spines, and the calm is not peace. It's confidence. The confidence is earned. When most reef fish meet a threat, they flee. The lionfish does the opposite. It turns and aims those long dorsal spines directly at whatever's bothering it, holding its ground like a knight presenting a wall of pikes. Each spine is sheathed in thin skin, and when one punctures, that skin slides back and opens channels along the sides that run venom into the wound. A compound that hits the nervous system and produces immediate, severe pain in anything unwise enough to make contact. It doesn't run because it rarely has to, and it is always eating. A lionfish can expand its stomach up to 30 times its normal volume, which lets it take prey nearly its own size and keep hunting through the day without pausing to recover space. Marine biologists watched it use a genuinely odd tactic too. It blows small jets of water at the face of the fish it's stalking. The jets scramble the target's sensory read of the situation, and this is the strange part. The confused fish often turns to face the current and swims straight toward the lionfish's mouth instead of away from it. It corners prey against the rocks with those spread fins and finishes with a suction strike so fast the prey goes in whole. Here's the number that turns a pretty fish into an ecological wrecking ball. A single female lionfish can release up to 2 million eggs in a year. 2 million! In waters where it has no natural predators, that arithmetic is the whole story. It doesn't need aggression to overrun a reef. It just needs to keep eating and keep spawning, and the reef empties out around it. The most elegant animal in this section is dangerous less for its venom than for its math. Great barracuda! The next one is a danger you can actually prepare for, and the preparation is oddly specific. Take off anything shiny. The great barracuda, Sphaerena barracuda, is a 2-meter silver torpedo, one of the fastest visual hunters on the Pacific Reef, and it locks onto flash. In murky or shallow water, the glint of a metal watch, a bracelet, a dangling piece of jewelry reads to a barracuda exactly like the flicker of scales on a fleeing fish, and it will strike at that flash before any part of its brain has time to reconsider. Divers are told to lose the metal for a reason. A wristwatch has cost people fingers. What makes that so dangerous is the speed. The barracuda's body is long, smooth, and cylindrical, with its fins set far back toward the tail, and that layout lets it go from a dead stop to full speed almost instantly. Over 40 kilometers an hour, launched like something fired rather than swum. Human reaction time simply isn't in the conversation, and the strike itself is built to sever. The lower jaw juts out past the upper, and the teeth are long, flat, and sharpened on both edges like double-edged daggers, set so they fit into sockets in the opposing jaw when the mouth closes. That arrangement lets a barracuda make a clean, guillotine-style cut straight through bone and muscle in a single pass. For all that, they're weirdly companionable. Barracuda are intensely curious, and they'll shadow a diver for long stretches, hanging motionless a few meters off, big eyes fixed and unblinking, just watching. Sometimes for the entire dive, before drifting off into the blue. It's a strange thing to be studied that closely by something that fast. I'll close the barracuda on a grim, dry note, because it earns one. As a top reef predator, it accumulates ciguatoxin over its lifetime, the same toxin the moray builds up, and it's one of the major carriers of ciguatera in the Pacific. So the animal that can take a finger with a glance is also on the plate, quietly one of the more hazardous fish in the ocean. It gets you coming and going. Humboldt squid, which leaves the one that doesn't hunt alone. Everything else in this section has been a solo operator. The last one moves in a mob. Fishermen off the Pacific coast of the Americas call it the Diablo Rojo, the Red Devil, and the name comes from what it does when it rises out of the deep in numbers. The Humboldt squid, Dositicus gigas, grows up to 2 meters long, weighs more than 50 kilograms, and travels in shoals that can number over 1,000 animals, moving at up to 25 kilometers an hour on jets of water. And they don't just hunt together. They flicker, the skin strobing red and white, and they come up as a coordinated wall. Here's how ruthless the coordination is. If one squid in the group is injured, snagged on a fishing line, wounded in the chaos, the others don't hesitate, and they don't mourn. They turn on it and take it apart in seconds because a struggling packmate is just more food. The loyalty runs exactly as far as being useful and not a millimeter further. They pull off a physiological trick to make the hunting possible too. Humboldt squid spend much of the day down in the ocean's twilight zone, hundreds of meters deep, in a layer where oxygen is so scarce that most active animals can't function. They survive it by throttling their own metabolism far down, idling through the low oxygen band, and then rising to the surface at night to hunt at full power. And when they grab something, they grab it with tools built for the job. Each of the hundreds of suckers along their tentacles is ringed with sharp, chitinous teeth like a rim of tiny circular saws. So once a sucker lands on prey, the prey does not slide back out. Here's the fact I want to leave this whole section on because it's the biggest one. Deep-sea cameras revealed that Humboldt squid use complex, shifting patterns of light across their skin as a visual language, a way to signal to each other in the dark, to coordinate a group strike, to avoid colliding, to divide up prey before the rush begins. 1,000 animals moving at speed in near total darkness, talking to each other in flashes of light across their own bodies, organizing the attack before it lands. Think about that for a second. The ocean's most aggressive squid isn't just a mob. It's a mob with a language. Stellate puffer. We're at the end, and I've saved the rule breakers for it. Everything so far has fit a category: venom, teeth, ambush, numbers. These last three don't. One is a fish people pay a fortune to eat on purpose. One is a crab that lives in a tree and comes down for the birds. And the last one is the smartest animal in any ocean, which uses that intelligence in a way that should genuinely change how you think about the top of the food chain. Start with the paradox. There is a fish in the Pacific so dangerous that eating it is a delicacy. A thrill precisely because it could go wrong. That's the puffer, and the giant of them here is the stellate puffer, Erythron stellatus, the largest puffer fish in the Pacific, a slow, round, almost comically friendly-looking thing. Its close relatives are the source of fugu, the Japanese dish where diners pay top prices to eat a fish that can finish a person if the chef's knife strays by a few millimeters into the wrong tissue. The danger isn't a rumor to make dinner exciting. It's the entire reason the meal exists. The threat lives in its organs. The liver, the skin, the gonads carry one of the most potent toxins on Earth, and the fish doesn't even make it. This is the same trick the blue-ringed octopus pulls. From the other end of this list, the puffer accumulates tetrodotoxin by taking in bacteria through its diet and storing what they produce. The remarkable part is that the puffer's own nervous system evolved to be completely immune to the toxin's blocking effect, so it can stockpile a genuinely dangerous dose in its body and feel nothing. One stellate puffer carries enough to affect around 30 adults, and there is no antidote to tetrodotoxin at all. Only, once again, keeping a person breathing until it passes. Now the defense is, because it has two more before the venom ever matters. The famous one is the inflation. Threatened, it gulps water into a special elastic stomach and swells up to 3 times its size, going from a fish into a taut ball studded with spines that were lying flat against its skin a moment earlier. Too big and too prickly for a predator to get its mouth around. And then there's the mouth. It looks like it has a soft, friendly beak, almost parrot-like. That beak is actually fused dental plates strong enough to crush the shells of clams and sea urchins, and strong enough to take off a human finger or snap a metal hook without much trouble. The gentle face is the disguise. I'll leave the puffer on its oddest fact, and it's a genuinely strange one, no dark turn required. Japanese researchers found the fish uses its toxin as a social signal. During spawning season, females release small amounts of tetrodotoxin into the water, and males track that toxic trail using their chemical senses to find them. So the deadliest chemical in the fish doubles as a perfume. Somewhere off the coast of Japan right now, a puffer is following a scent trail made of one of the most potent toxins in nature on a date. Leave that one exactly as weird as it is. Coconut crab. The next one shouldn't be on a list about the ocean at all, and that's the point. It lives on land, on the islands scattered across the Pacific, and if you threw it into the deep sea, it would drown. Meet the coconut crab, Burgess latro, the largest land-dwelling arthropod on the planet, a creature so committed to life out of the water that its modified lungs can no longer pull oxygen from the sea. It has an air-breathing chamber that has to be kept damp. The crab uses its rear legs to wet it, and through that, it breathes air efficiently enough to run an enormous body on dry land. An animal we'd call a crab that has to stay out of the ocean or it won't make it. Start there, because it only gets stranger. It climbs. A coconut crab will scale a palm tree 10 meters tall to cut coconuts loose and let them drop, and it's not shy about the height. And its claws, this is the number that reframes the whole animal, can clamp down with up to 3,300 newtons of force. That's in the range of a leopard's bite or a bear's, coming out of a crab. People instinctively file crabs under slow, harmless, eats seaweed. This one can crush bone, and it uses that. There's a famous field observation that tells you exactly what this animal is capable of. A coconut crab was recorded going after a seabird, a full-sized booby, as it slept up in a tree. The crab climbed to it, took the bird's wing in one claw, and broke it with a single squeeze, brought it down to the ground, and took it apart there, joined by other crabs that the scent had drawn in. A land crab that climbs trees at night to reach sleeping birds is not the animal anyone pictures when they picture a crab. So here's the honest summary of the coconut crab. It's a crab that breathes air, climbs palm trees, has the grip of a bear, comes down at night to take apart seabirds, and would drown in the ocean it's named after. Sometimes an animal doesn't need a lesson attached to it. Sometimes it's just that strange, and the right thing to do is let it stand there being that strange and move on. Orca, which brings us to the last animal on this list, and it's the right one to finish on because it sits above every other creature we've talked about. Not the most venomous, not the biggest, the smartest. The orca, Orcanus orca, is the apex predator of every ocean on Earth, the Pacific included, and despite a common name built to frighten, it's actually the largest member of the dolphin family. Attacks on people in the wild are essentially unheard of. That's not why it closes this video. It closes it because of what its intelligence lets it do to everything else, including the largest animal that has ever lived, the blue whale, which pods of orcas have been recorded hunting and bringing down as a coordinated team. Everything about the orca is coordinated. They hunt in family groups where individuals take assigned roles, some driving prey, some sealing off escape routes, one delivering the finish. Off the Pacific ice, pods have been documented swimming in a line straight at floating ice floes to push a single perfect wave up and over the top, sliding a resting seal off the ice and into the open water where the rest are waiting with mouths open. That is not instinct. That is a plan, executed by animals that clearly agreed on it first. And they carry a piece of equipment that makes them more unsettling still, an organ of fatty tissue in the forehead called the melon that focuses beams of sound through the water. With it, an orca can effectively see inside another animal's body at a distance, read the density of its organs, judge its condition, and, researchers believe, even tell whether a female shark is carrying young before the hunt begins. There's also a habit that's hard to look away from. Orcas play with their food. They'll strike a seal or a dolphin with those massive tail flukes and send it dozens of meters through the air, partly to subdue it, and partly, it seems, to train the young ones, keeping prey in motion while the calves learn the timing. Warmth and cruelty in the same animal. Orcas have distinct cultural dialects. They show deep social bonds within their families. They grieve, and they run their hunts with a surgical detachment that nothing else in the water can match. And here is where I'll leave you, because this is the last fact. And it's the one that says everything about what the top of the Pacific food chain really looks like. Off the coasts of California and Australia, scientists have watched orcas hunt the great white shark, the animal we open the shark section with, the one that comes up from the dark like something launched. The orcas don't overpower it in a straight fight. They outthink it. They flip the shark upside down and hold it there, which sends it into a strange, involuntary trance called tonic immobility. A great white, turned over, simply goes still, unable to move. And while it hangs there, paralyzed by its own biology, the orcas open the area just below its pectoral fins, remove the shark's liver, rich, enormous, packed with nutrients, and take only that. Then they swim on, and they leave the rest of it to sink.